Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review what was covered in week 2. So this week was all about operations with fractions and mixed numbers. Let's start with multiplying and dividing. So it's actually pretty easy to multiply two fractions. All you need to do is multiply the tops and multiply the bottoms. Now, when you give an answer, make sure it's simplified. This fraction actually can't be simplified because 12 and 55 don't have any common factors. Let's look at the second example, 5/8 of 64. Well, as it says over here, of means multiply. So I'm just going to change that to a times. Now, it also says here, when you have a whole number, write it over 1. So if I want to times by 64, I'm just going to write 64 as 64 over 1. So now that we're multiplying 5/8 by 64 over 1, I can just multiply the tops and multiply the bottoms. But sometimes you might have to multiply by a big number like 64. So when that happens, let's see if you can cancel. Let's see if there's anything on the top and anything on the bottom that share a common factor. Well, it turns out 8 and 64 have a common factor of 8. So I can divide 8 by 8 to get 1. And I can divide 64 by 8. It's okay to divide the bottom by 8 as long as I divide something in the top by 8. Now see, this calculation so much easier. Now it reduces to just 5 times 8, which is 40. 1 times 1 is 1. Of course, 40 over 1 is just 40, so I don't even need to write the denominator. Then we're done. So we'll use cancelling in something like this as well. Doing 32 times 33 without a calculator, remember we're not using calculators for this topic, that would be very hard, take a long time. Similarly, 77 times 64 takes a long time. So let's see if there's anything on the top and anything on the bottom that share a common factor. Well, 32 goes into itself once and goes into 64 twice, so I can cancel like that. Similarly, 11 goes into both of these numbers. So I can divide 33 by 11 and then divide 77 by 11. So what you do to the top, you must do to the bottom. So now this is so much easier. Rather than doing 32 times 33, all I have to do is 1 times 3 is 3, 7 times 2 is 14, and I'm done. Now, when you're dividing fractions, what you do is leave the first fraction alone, so it's not going to change. Then we flip the second fraction and we change the division to a times. So 2/9 divide 1/4 gives 2/9 times 4 over 1. Now it's a multiplication. I'm just going to do what I did before. I am just going to multiply the tops, multiply the bottoms, and I'm done. So what about this last one, 3 divided by 1/3? Well, whenever you have a whole number, write it over 1. This is 3 over 1 divided by 1 over 3. A lot of people look at this and they think, oh, cool, the answer's 1. No, 3 times 1/3 equals 1. 3 divided by 1/3 is the same as 3 over 1. Now I'm going to make it a times and flip the second fraction. 3 divided by 1/3 is just 9, or 9 over 1. All right, let's now look at addition and subtraction. So unfortunately, addition and subtraction of fractions is a little bit harder than multiplication. That's because if you have a fraction like 1/4, this line here means divide. Division works a lot better with multiplication than it does with addition or subtraction. So you can only add or subtract fractions when their denominators are the same. If they are not the same, like in this question, you have to make them the same using equivalent fractions that we learned about last week. When you do add or subtract fractions that have the same denominator, you only add or subtract the numerators, the top numbers. All right, let's look at this example, 1/4 plus 5 over 8. Clearly the denominators are different. So what I have to do is make them have the same denominator. So I can make this denominator 8 if I multiply it by 2. But remember the golden rule of fractions, what you do to the top, you must do to the bottom. What you do to the bottom, you must do to the top. I can multiply the bottom by 2 as long as I multiply the top by 2. So that means 1/4 is actually the same as 2 over 8. 2/8, 1/4, both equal to 0.25. They're the same thing. But now I've written this sum in a way that the two fractions have the same denominator. So when that happens, you only add or subtract the numerators. So I go 2 plus 5 is 7, and I leave the denominator alone. So my final answer is 7/8. It works very similarly for subtracting. So 9 and 6, clearly the denominators here are different. So I can't multiply 6 by a number to get 9. So what I'm going to do is I'm going to find the lowest common multiple of these two numbers. Now that turns out to be 18. 18 is the lowest number divisible by 9 that is also a multiple of 6. I want to make both of these denominators 18. So for the first fraction, if I multiply this bottom number by 2, this denominator becomes 18. Once again, I chose 18 of all numbers because it's the lowest common multiple of 9 and 6. So once again, what I do to the bottom, I must also do to the top. So over here for this fraction, I want it to have a denominator of 18. So I need to times 6 by 3 to get 18. If I times the bottom by 3, I must times the top by 3 also. So 7 over 9, when I times top and bottom by 2, I get 14 over 18. 1 over 6, I times top and bottom by 3, becomes 3 over 18. Okay, so I've used equivalent fractions. These two fractions are the same, both equal like 0.7 recurring. These two fractions here are the same. They're equivalent fractions, but I've just written it in a way that I can subtract them because denominators are equal. So now I just subtract the numerators. I just subtract the top numbers. 14 minus 3 is 11. Keep the same denominator. That's my final answer. All right, let's now look at operations with mixed numbers. So in case you've forgotten, a mixed number is something that looks like this. It's got a whole number part and a fractional part. When you have to perform operations, like you have to add, subtract, multiply, or divide mixed numbers, first turn them into improper fractions, then just do all the things I said in the previous slides. So let's look at this example here. I'm going to convert both of these to improper fractions. So what you do is you take the whole number part and you multiply by the denominator, then you add the numerator. That is the new numerator. So I go 2 times 4 is 8, plus 1 is 9. That goes on top, and I always keep the same denominator, 4 and 4. Let's do the same here. So I want to convert this to an improper fraction. So I go 1 times 6 is 6, plus 5 is 11. 11 goes on top, and I keep the same denominator. So this is 9 over 4 minus 11 over 6. Now I'm going to use the strategies on the previous slide. I need to make these two have the same denominator before I can subtract. So the lowest common multiple of 4 and 6 is 12. I need to times 4 by 3 to get 12, so I must also times the top by 3. If I times this by 2, then this denominator will also be 12. If I times the bottom by 2, I must times the top by 2. So what I end up with is 27 over 12 minus 22 over 12. So I just subtract the numerators and leave the denominator alone. 5 over 12, my final answer, then I'm done. All right, let's look at this question here. Now we're dividing two mixed numbers. So I'm going to convert this to an improper fraction. 7 times 5 is 35, plus 4 is 39. So that goes on top, and I keep the same denominator. Changing this to an improper fraction. 4 times 3 is 12, plus 1 is 13. So that goes on top. I leave the same denominator. So now I want to divide fractions. Remember, the way that I do this is I flip the second fraction and I change the division to a times. So rather than doing 39 times 3, I might see if I can cancel. Turns out 13 goes into itself once, and 13 goes into 39 3 times. So I've made this a much easier sum. On top is just 3 times 3, which is 9. On the bottom is 5 times 1, which is 5. So in the previous example, I got a proper fraction as my answer, numerator less than denominator, but here I've got an improper fraction as my answer. So it's just a convention in maths. If you get an improper fraction as your answer, you should convert to a mixed number. So how do you go the other way? How do you convert an improper fraction to a mixed number that looks like that? Well, this is a division. It's 9 divided by 5. So 5 goes into 9 once, remainder 4. So we put the quotient here and the remainder here, and once again we keep the same denominator. 9 over 5 is the same as 1 4/5. All right, let's now look quickly at a worded problem. So each student in a class had blue, brown, or green eyes. 5/6 have blue eyes. 1/8 have brown eyes. What fraction of students have green eyes? So we just have to be able to rewrite this information here using only mathematical symbols. So we're talking about one whole class. What I want to do is take away the fraction with blue eyes, take away the fraction with brown eyes, and what's left will be the fraction with green eyes. So to subtract these, I need to make sure they have the same denominator. So 1 isn't really a fraction, but remember I can write it as 1 over 1. So the lowest common multiple of 6 and 8 is 24. That's the lowest number divisible by 6, but also by 8. So what I'm going to do is I'm going to make all of these denominators here 24. So I would, of course, need to times this by 24. What you do to the bottom, you must do to the top. So to go from 6 to 24, I need to multiply by 4. What I do to the bottom, I must do to the top. To make this fraction also have a denominator of 24, I need to multiply it by 3. What you do to the bottom, you must do to the top. So I'm left with 24 over 24. That's what 1 whole means. 5 over 6 is the same as 20 over 24. And 1 over 8 is the same as 3 over 24. So now I'm just going to subtract the numerators, the top numbers. 24 minus 20 minus 3 equals 1. And remember, you always keep the same denominator when adding or subtracting. So in this class, 1/24 have green eyes because 1/24 plus an eighth plus 5/6 gives us one whole class. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.